For our next laboratory investigation, we're going to be taking a closer look at periodic motion, specifically for spring mass systems. We've already talked about in class how if you have a mass hanging from a spring and you pull it down and displace it from its equilibrium position, when you let go, it's just going to bounce up and down or oscillate about that equilibrium position. Well, what are some things that we could measure about this system? Well, we could measure the mass that's attached to the spring. We could know something about the spring, like the spring constant. And we could measure how long it takes this spring mass system to go up and down once, to go through one complete cycle of its oscillation. We call that the period, the time for one complete cycle. Well, we've already talked about the fact that as mass increases, the amount of time it takes for that to go through one complete cycle also increases. So there's a relationship between the mass of the spring mass system and its period, how much time it takes to go through one complete cycle. So that's going to be our investigation. We're going to look at this quantitatively to see if we can come up with an equation to be able to predict the period of a spring mass system if we know what the spring mass system's mass is. So our purpose statement will be to determine the relationship between the period and the mass of an oscillating spring mass system. Well, in order to do that, we're going to have to collect for different masses what the period is going to be, how much time it takes to complete one full cycle. We're going to have to do this for 6 to 8 different masses at least, and then measure 6 to 8 different periods in seconds. Once we get that data, we can find out how it's related by making a graph. We're going to put our independent variable, the mass, on the x-axis, and the measured period, the time for one complete cycle, on the y-axis, to find out graphically how are those two things related. Once we find out what the graph looks like, if it's not linear, we can linearize it to make it look like a linear relationship. And then either the original graph or the linearized one, we can get our equation for how period and mass are related from that. So let's talk about data collection. For each specific mass hung on the spring, you want to measure how much time it takes for one cycle. We call that a period. Well, you could try to measure that directly just for one cycle. In this case, it was about 0.501 seconds. Or you could measure the time it takes for multiple cycles, let's say 7 complete cycles. And if this one took 3.604 seconds to go through 7 full cycles, we just divide that number by 7, and that will give us the number of seconds it takes for one cycle. That again is our period. So if you were looking at this video for data collection, or you're collecting it yourself, you could try to measure just the time for one cycle, or measure more than one cycle, divide by the number of cycles, and you should be getting fairly close numbers either way you do it. Probably the more accurate way would be to measure multiple cycles, divide by the number of cycles, and that's going to give you the average time for the period, the time for one complete cycle. So if you're doing this in the lab, you're just going to be adding more and more mass and getting that period measurement. If you're collecting data with a video, the video will automatically be adding more mass for each trial, and then you can use the video to estimate the amount of time it takes for one complete cycle. If you're using a video and you're watching this on YouTube, remember you can use the period key to advance the video through frame by frame forward, or the comma key to advance it back, just to kind of get a better estimate of the time for one complete cycle. So for data collection, we're going to be using different springs just so we have some varied data. It's going to help in our conclusion discussion later on. So if you're lab group A or D, you're going to be using a green spring in the lab. Or if you're using a video for data collection, click on the link titled Spring Number 1. Labs group B and E, you're going to be using a red spring, or click on the video titled Spring Number 2. And lab groups C or F, you'll be using a yellow spring in the lab, or you can click on the video titled Spring Number 3. Remember, you're going to be collecting 6 to 8 different masses and periods, and then graphing mass versus period.